Hello students, we have learned about natural numbers, whole numbers and their properties. Today we are going to review in brief what we have learned earlier. So let us quickly review what we have learned earlier. Students, we know that numbers are used for counting. Things can be counted with the help of numbers. For example, 6 chairs convey that the quantity is 6. These numbers are called natural numbers. Natural numbers are 1, 2, 3, 4 and so on. They are unlimited. Thus we can say that numerals which are used in counting things, that is 1, 2, 3, etc. are called counting numbers or natural numbers. When we add any two natural numbers, we get a third number which is also a natural number. For example, 100 is a natural number. When you add 50 to 100, 50 is also a natural number and the sum you get is 150, which is also a natural number. Now let us see what happens when we subtract two natural numbers. Example A, 100 minus 50 equals to 50. 100 is a natural number. Also, 50 is a natural number. Example B, 20 minus 20 equals to 0. 20 is a natural number and the answer we got is 0. 0 is not a counting number. It is not a natural number. When we add 0 to any natural number, we get a new set of numbers called whole numbers. Whole numbers is denoted by W and is written as W equals to 1, 2, 3, etc. Thus, natural numbers or N equals to 1, 2, 3, 4, etc. And whole numbers or W equals to 0, 1, 2, 3, 4, etc. Students, you have to remember the smallest natural number is 1. The smallest whole number is 0. The largest natural number cannot be determined as there are unlimited natural numbers. Every natural number has its successor and a predecessor, 2 except 1. Properties of whole numbers. Every set of numbers has few unique properties. Let's explore all the properties of whole numbers. Closure property. If we add or multiply two whole numbers, then the sum or product will always be a whole number. This property is known as closure property of addition or multiplication. If A and B are two whole numbers, then A plus B equals to C is also a whole number, or A into B equal to C is also a whole number. For example, example, 17 plus 19 equals to 36, where 17, 19 are the whole numbers and the sum we got 36 is also whole number. Thus, we can say that whole numbers are closed under addition and multiplication. That is, closure property is satisfied for addition and multiplication. Students, note that closure of whole numbers does not hold true for subtraction and division. Commutative property. When two whole numbers are added or multiplied, the sum or product does not change even if the order in which the numbers are added or multiplied is changed. This is called commutative property of addition or multiplication. In short, we can say that the sum or product of two whole numbers remain the same if the order of the number is changed. This property is called commutative property of addition and multiplication. If A and B are two whole numbers, then A plus B equals to B plus A, or A into B equals to B into A. For example, 71 plus 19 equals to 19 plus 71 equals to 90, or 9 into 4 equals to 4 into 9 equals to 36. Thus, we can say that the addition and multiplication of two whole numbers are commutative. Associative property. The sum and product of three whole numbers remains the same even if the grouping is changed. This property is called the associative property. If A, B and C are three whole numbers, then A plus B plus C equals to A plus B plus C equals to A plus C plus B, and A into B into C equals to A into B into C equals to A into C into B. Example 1. 5 plus 3 plus 7 equals to 8 plus 7 equals to 15. 5 plus 3 plus 7 equals to 5 plus 10 equals to 15. 5 plus 7 plus 3 equals to 12 plus 3 equals to 15. Example 2. A into 3 into 2 equals to 24 into 2 equals to 48. 8 into 3 into 2 equals to 8 into 6 equals to 48. 8 into 2 into 3 equals to 16 into 3 equals to 48. In each case, the answer is same. Thus, addition and multiplication of three whole numbers is associative. Students, note that associative of whole numbers is not satisfied for subtraction and division. Distributive property. Distributive property is a property of multiplication. in which multiplication distributes over addition. If A, B and C are three whole numbers, then A into B plus C equals to A into B plus A into C. We are distributing or breaking B and C into two parts and multiplying each of them, that is B and C, with A. For example, 3 into 7 plus 4 equals to 3 into 7 plus 3 into 4 equals to 21 plus 12 equals to 33. Example 2. 9 into 5 plus 3 equals to 9 into 5 plus 9 into 3 equals to 45 plus 27 equals to 72. Now B. Multiplication distributes over subtraction. If A, B and C are three whole numbers, then A into B minus C equals to A into B minus A into C. If B greater than C, we are distributing or breaking B and C into two parts and multiplying each of them with A. For example, 3 into 7 minus 4 equals to 3 into 7 minus 3 into 4 equals to 21 minus 12 equals to 9. Additive identity. When 0 is added to any whole number, the value of the whole number remains the same. Thus, 0 is called the additive identity of whole numbers. Thus, if A is a whole number, then A plus 0 equals to 0 plus A equals to A. For example, 7 plus 0 equals to 0 plus 7 equals to 7. Multiplicative identity. When a whole number is multiplied by 1, the product is the number itself, or if the number 1 is multiplied with any whole number, the product is the number itself. Let A be a whole number, then A into 1 equals to 1 into A equals to A. For example, 8 into 1 equals to 1 into 8 equals to 8. Properties of 0. 0 added to any given number gives the same number. For example, 91 plus 0 equals to 91. 0 multiplied to any number gives 0 always. For example, 81 multiplied by 0 equals to 0. 0 subtracted from any number gives the same number. For example, 18 minus 0 equals to 18. When 0 is divided by any number, we get 0. For example, 0 divided by 5 equals to 0. Division by 0 in mathematics is not defined. If A is a whole number, then A divided by 0 is undefined. For example, 91 divided by 0 is undefined. That is no answer. The simple explanation for this could be, if we have 15 items but no people to whom it can be given, so it has no answer. Other properties of whole numbers. Every number has its predecessor except 0 and a successor. For example, 19 is a predecessor of 20 and successor of 18. Likewise, successor of 81 is 82. All natural numbers are whole numbers, but all whole numbers are not natural numbers because 0 is a whole number but not a natural number. 0 is the smallest whole number. We cannot find largest whole number because every number has its successor. Students, remember these properties of whole numbers. It will be very helpful to you in solving the sums. Solve the following. Write the successor and predecessor of 9888. Student, successor is nothing, number that comes after, and predecessor is nothing, number that comes before. In short, successor is after number and the predecessor is before number. It is very easy to find the successor and predecessor of the given numbers. In order to get the successor, we have to add 1 to a given number. And to get predecessor, we have to subtract 1 from the given number. So, now let us find out the successor and predecessor of 9888. Successor of 9888 is 9889. Adding 1 to 9888, we get 9889. Now, let us find out the predecessor of 9888. Predecessor of 9888 is 9887. Subtracting 1 from 9888, we get 9887. Now, question number 2. Find the sum of 637 plus 608 plus 463 by suitable rearrangement. Students, in order to solve this sum, we have to look at the ones place and we have to regroup or rearrange the given numbers in such a way that we get 0 at the ones place and also we get the benefit of 0 or zeros so that we can able to solve the given sum quickly, say within 1 minute. Thus, checking units place or ones place of each number such as 637, 608 and 463. We observe that 7 plus 3 equals to 10. Where by adding 637 and 463, we will get the benefit of zeros. Thus, rearranging and regrouping the numbers properly, we get 637 plus 463 plus 608. Students, note that in each group we have to write 2 numbers. If the given numbers are in odd, then one number will remain ungrouped or unpaired. Students, in this sum, we have been given 3 numbers. So, 608 remain ungrouped. Students, after regrouping the numbers, we have to solve the bracket and then we have to add ungrouped number to the sum of group numbers. Thus, adding 463 to 637 and keeping ungrouped number 608 as it is, we get 1100 plus 608. Students, now we have to add 608 to 1100. Thus, adding 608 to 1100, we get 1708. Thus, 637 plus 608 plus 463 equals to 1708. Now, question number 2. Find the product of 250 into 987 into 4 by suitable rearrangement. Students, in order to find the product, we have to rearrange the numbers in such a way that we get the fastest answer and we get the answer mentally without using pen and paper. For getting the fastest answer and solve the sum mentally, we have to look at the numbers and we have to regroup the numbers in such a way that we get the benefits of 0 or zeros by multiplying such numbers. Thus, observing each numbers like 250, 987 and 4, it becomes clear that multiplying 250 by one digit number 4, we will get the fastest answer. Also, we will able to solve the answer mentally. Thus, rearranging the numbers properly, we get 250 into 4 into 987. Students, after rearranging and regrouping the numbers properly, we have to solve the bracket where we have to multiply 250 by 4. Then we have to multiply the product of 250 and 4 by 987. Students, we know that when we multiply any number by tens, we put 1 0 at the end, that is in ones place, and we multiply the remaining digits, thus writing 1 0 at the end and multiplying remaining digits like 25 by 4, we get 1000. Students, now we have to multiply 1000 by ungrouped number 987. Students, in order to multiply 1000 by 987, mentally we have to put 3 zeros, as in thousands there are 3 zeros at the end, and we have to multiply 987 by 1, as we know that when we multiply by thousands we put 3 zeros at the end and we multiply remaining digits, thus writing 3 zeros at the end and multiplying 987 by 1, we get 987,000. Thus, 250 into 987 into 4 equals to 987,000.